Assalamualaikum warahmatullahi wabarakatuh and good evening. Today we are going to present about the lab 4, which is disc brake, inspection, removal and refitting. This presentation is for subject Bmma 3503, which is vehicle brake system. Next. This is the list of our group member. Our group member consists of 5 members, which is MOHAMAD bin SOULIHEN, HERLIE JOLISON, ARIF bin FAIZAL EFFENDY, ZAINUL bin KAMARUDIN, and lastly MANOJ KRISHNAN. This presentation is prepared for Professor Marja Dr. Muhammad Zahir bin Hassan. Next. First of all, for the introduction, the main objective for this lab is to inspect the condition of master cylinder assembly. Next is to replace part of master cylinder assembly, and lastly to name all parts of master cylinder assembly.
Hi guys, I will explain more of the brake disc part. Okay, first is the lock pin, second is the guide pin, third is the guide pin seal, fourth is brake mounting bracket, fifth is pin boots, and six is seal ring, seven is piston boots, eight is piston, nine is piston seal, 10 is brake cylinder body, 11 is inboard brake pad, 12 is outboard brake pad, and 13 is brake pad shim, and 14 is brake pad clip. Next. Okay, next I'll explain more regarding the condition of the brake parts we have found through this lab. Okay, first of all, wear indicator. Wear indicator is the metal which is attached to the brake pad, which indicates whether the condition of the brake pad is whether in good or in bad condition, or whether need to be changed. Okay, as long through this laboratory, we conclude that the wear indicator is still in good condition. Next is this brake surface. This brake surface still in good condition, and it shows the results from the dial gauge which we used in the laboratory, which shows that it doesn't have any bumps or dents in the brake surface. Next is the outboard brake pad. Okay, first of all, the condition is still good, and the wear is moderate wear, which means it still can be used and can be changed when the wear is becomes more weaker, and the thickness of the outboard brake pad is 6.68 mm. Next will be inboard brake pad. Okay, the condition also is still good, and it indicates a moderate wear, and the thickness will be 7.21. Third is piston. Piston is still in good condition and no dent, and somehow it has some rust residue on the surface of the piston, so we need to be cleaned so that it gives a smooth flow and free flow of the piston when there's action or pressure is applied. Third will be cylinder bore, which also has rust residue and need to be cleaned so that the flow of the cylinder and also pressure which is applied will be transferred to the brake pads well, and it gives a better performance. That's all from me. Thank you.
So for the synopsis and theory for this lab is this brake has a metal disc or rotor inside of the drum, and use pair or plate line shoes or pad that pose against the rotating disc to produce braking. Caliper has one or more piston with a seal and dashboard per each. And during brake hydraulic pressure, behind each piston push it outward. Next is the existing or frictional contact slows and stop the disc and wheels. And lastly is the disc brake is harmful, which is contain asbestos, so need safety requirement for cleaning any component of this brake. That's all for me.
Okay, next I will explain about procedure on removing disc brake assembly. Okay, first of all, we loosen the wheel nuts, then jack the car at considerable height and place axle stands under the car. Then remove the tire and wheel assembly to get better working access. 4. Disconnect hydraulic cable and flush all the brake fluids out of a master cylinder into a bottle. 5. Use proper tools to open 2 screws at the brake assembly. And the last one, take off the brake assembly from the brake fluid cable. As we can see from the figure, the jack, and we remove the tire and we remove the brake assembly from the brake fluid cable. Okay, next. Uh, while after we remove all the brake assembly, we do the inspection. Okay, first we inspect the surface condition of this brake, front and rear. Second, check the thickness of the brake pad, replace new brake pad if necessary. Third, inspect the condition of brake assembly parts and write your finding on the table given. We see later on the table given. And the fourth, using micrometer, measure the disc at six different places around the diameter of the rotor, about 10 millimeter from the outer ring. 5. Write the findings on the table below, so we see the table below for the finding. Okay. 6. Chalk this brake surface and rub it with the brake shoe and write your finding. This brake we want to see the contact surface this brake with the brake pad. Okay, next, clean off all clean off after check. Then check the lock pin and guide pin straightness by rolling it on the table. Visually check its straightness. And last, name each of the disc brake assembly part and write it on the table given. We will see all the results later on the table given. Okay, the final, after we do the inspection, we refit back all the first assemble a brake fluid cable on the brake assembly and tighten the nut. Assemble the brake assembly on the mount and tighten the screws. Place the indicator plunger at a point 13 mm from the outer edge of the disc. Set indicator to 0 and rotate the disc. Write your result on the table below. Run out should not exceed 0.05 mm. Next, fill in the brake fluid and do a bleeding process until the brake is in a good working condition. And last, assemble back the tire and check the brake handling. So as we can see the photo, refit back the brake assembly, and this is the assembly of the brake system for the disc brake. Okay, that's all from us. This is the experiment result.
So for the experiment result, there are 4 tasks that given and 4 condition finding. First is run of measurement. There are positive and negative reading that indicate by the dial gauge. This is due to the surface of this brake. Second is this thickness measurement. There are 6 measurements that being taken from this lab. First is 6.29 mm. Second is 6.16 mm. Third is 6.35 mm. Fourth is 6.65 mm. Fifth is 6.51 mm. Sixth is 6.47 mm. Next is rub test. The rub test indicate by the surface of this brake is in bad condition because some of the surface is not fully contact with the surface of brake pad. Lastly, guide pin or lock pin straightness. The condition is in good condition. It moves smoothly in flat surface. That's all for me.
Hi, Assalamualaikum. Welcome back to me, ARIF Trainer bin FAIZAL EFFENDY. For question 1, based on your finding, what is the condition of brake pad? Should it be replaced with the new pad? So, from the result that we figure out, the minimum the thickness of outboard brake shoe is 6.68 and inboard brake shoe is 7.21 mm. So the minimum thickness of brake pad is between 3 to 6 mm. As shown from the diagram beside, we can look at light wear, moderate wear, and service soon. So our brake pad is between 7 to 6. So in the moderate wear. So the surface, so the brake pad already in good condition. And then we need to look at the surface. The surface of brake pad also no crack, and the surface are able to evenly contact with the rotor. So the brake pad no need to be replaced for the time being. So next we jump to the question number 2. So for question number 2, list 2 causes of rotor thickness variation. What is the correct repair procedure of thickness variation? So HERLIE JOLISON told us that our disc rotor already in a bad condition. This is because of the rotor thickness variation. So first thing, this rotor thickness variation is caused by an excessive lateral run out. So lateral run out is the amount of the side to side movement of the rotor as it rotates. And then either way, this variation caused by the irregular brake friction materials pattern. The uneven clamping force can cause rotor thickness variation if the brake pad is made of abrasive material. So the correct repair procedure are by clean the rust on the wheel hub, on the disc rotor. So other way is to skim the surface of the rotor. So on the picture given, we can, this is a skim procedure is how we need to correct repair procedure for the rotor thickness variation. This is a procedure, but today I think people will change the rotor, this rotor for get a good braking performance. Okay, we jump to the question number 3. So question number 3, what do you understand about run out measurement data? So from the experiment, we ran out measurement data to get the height spot of brake rotor. So from data we found, use dial gauge to obtain the height spot on the brake rotor. So by place the dial gauge at the contact point of the rotor and then rotate the disc, then we can see the dial gauge show the reading and we can figure out where the place of height spot of brake rotor. So next, so for question number 4, what is your finding for guide pin or lock pin straightness check? So what can happen to your disc brake system if guide pin or lock pin is not straight? So guide pin and lock pin is still in a good condition and still not bent. So both can evenly smoothly roll on a flat surface. So if the guide pin and lock pin is not straight, it could experience noises and problem when apply force on the brake rotors. So lastly, if the caliper are not contacting the rotor at the right angle, so the brake may stick or grab while driving, or you may hear a scratching noise and then your wheel will screech. Next. So for part conclusion, I will give to our host, NAIM HAZIQ.
So for the conclusion, based on the lab session, we could learn about how to inspect the condition of this brake and how to assembly in real situation. Compared to other SEM, we actually do the lab session by referring the video, but today we could have the opportunity to come to the lab session and face to face and be able to understand it more clearly. We also be able to open and refit the brake pad correctly. We also learn to replace part of this brake system if it is in bad condition, and we also could gain new knowledge about name all parts of this brake assembly. That's all from us. Thank you.